XJet NanoParticle Jetting, manufacturing high-strength metal parts with the ease and versatility of inkjet-based additive manufacturing. Here's how it works. The challenge is to enable metal to be deposited in a liquid form so it can be jetted from inkjet nozzles. To do this, the XJet system uses nano-sized particles suspended within our patented liquid formula. Eliminating inefficient lasers, this metal liquid formula can be jetted from the printing heads, representing a revolution in metal additive manufacturing. The metal materials are packaged within specially adapted cartridges that are easily loaded by hand into the XJet system. Because there's no powder vat, XJet uses only the material required, saving space and eliminating the need for handling metal powders. Send your STL design to print. You're now ready to print your metal part. The print head deposits a fine layer of metal liquid droplets and support material where needed onto the system build tray. With each pass of the print head, the metal part builds up as the tray descends. The metal liquid formula and the support material are jetted from many thousands of printing nozzles simultaneously in a process that's up to 5 times faster than laser metal printers. Temperature of up to 550 degrees Fahrenheit or 300 degrees Celsius causes the liquid jacket around the metal nanoparticles to evaporate, allowing the stochastic metal particles to achieve virtually the same metallurgy and density as traditionally made metal parts. After printing, the support component, which is made of a different material, is easily disintegrated and removed. To finalize the process, the printed parts go through sintering. With layer thickness of a few microns, the result is never-before-seen levels of detail, surface finish, and accuracy, with no compromise on speed or build time. Welcome to a new era in metal additive manufacturing.